Hi, in this video I'm going to show you how I set up the whole infrastructure in Amazon Cloud to run my service. So at this point, I'm actually very excited because we have everything built and tested and ready to be launched on Amazon. So I have 3 microservices, I have website, I have the client library that is running on mobile devices. I have Kafka in MongoDB, so all this that configured, and I just want to deploy it all in the cloud, in Amazon Cloud, and actually, well, be ready to be used. So normally, well, you would have those microservices probably deployed in a Kubernetes, and in a Kubernetes cluster that is managed by Amazon, and you would have Kafka also as a managed service in Amazon. Or other cloud provider. For me, that was too expensive, so just paying for all of those things just added up to hundreds of euros. So I did something simple, so that I already kind of explained. So I'm just, in the end, I just end up buying 2 EC2 instances, and I run everything on those EC2 instances. So every instance has one instance of Kafka, one instance of MongoDB, and one instance of each microservice that I need. And basically, yeah, this everything is duplicated on those 2 instances, and they run everything. So, but because it's all duplicated, because I have these 2 EC2 instances, well, one EC2 instance can go down, I can reboot it, I can install update on it, and the second one will continue to serve traffic because they both are connected to the load balancer, and the load balancer is available in 2 availability zones as well. And traffic from the load balancer is connected to the internet gateway, and that what is allowing the all the external connection come and be served by my microservices. So the whole thing is deployed in a VPC, a virtual private cloud, and let's go and see what I did. But before I do that, as usual, everything is available on the GitHub. So it's github.com artyom-kv kaboom-prod-environment. And now let's go and see what's in that project. So the idea was, again, to run those 2 EC2 instances. I wanted to prepare the images for those instances so that I just have minimal setup once they are deployed in Amazon. So for that, I used Packer. And here we have the Packer template. So what is Packer? Packer is basically a tool that can, based on an existing image, can create the new image that you can use for running the EC2 instance on Amazon. Well, it's not only that, but that's what I use it for. So in this case, I'm specifying the original instance that I want to use. That's Ubuntu 1864-bit Linux version. Originally I wanted to use T2 micro instance because one of them would come for free with the free tier on Amazon. I couldn't do it because that instance, it has only 1 GB of memory, and that was absolutely not enough to run everything I wanted to run on it. So I ended up actually running it as a T3 instances with 2 GB of RAM. But yeah, I had to change it later. So when I defined that, I also want Packer to run 3 shell scripts on that machine to set up Docker, set up MongoDB, and set up Kafka. In this case, I'm not going to actually configure Mongo or Kafka because I want to use the same Amazon image for both instances, and they basically just set up those tools, MongoDB and Kafka, but actual configuration will differ from machine to machine, and that's what I did later. To test that those scripts work, well, I used the Vagrant, so I set up Vagrant to have my virtual machine, and so again to run the same scripts on the virtual machine that is run by spawned by Vagrant. So once I was happy with what I got on the Vagrant, Vagrant controlled virtual machine, I was pretty confident that those scripts would work well on the when the Packer would use them for building actual instance. So that's why I use the Vagrant here. In the end, the Packer created me the image that I used later to set up my EC2 instances. So how I did that? So I have the CloudFormation template here, and for the rest of the video we're going to focus on this CloudFormation template. So this template accepts two parameters. One of them is the key pair to access my instances in the cloud, and the second one is the SSL certificate for the load balancer. So the load balancer, I want to accept HTTPS traffic on the load balancer, and then I terminate that HTTPS traffic on the load balancer, and I communicate from the load balancer to my instances using just HTTP. But to be able to accept HTTPS traffic, load balancer needs a certificate. That's where you provide it. So let's go through this CloudFormation template quickly. We have here the virtual private cloud setup with the subnet, and I also have here the internet gateway. So to be able to accept traffic from outside world. And here I linked my internet gateway to virtual private cloud. And then I create two public subnets. Those public subnets will be used to hold the load balancer, and I create the route table for those subnets to route all the external traffic coming from the internet gateway to those public subnets. I also define two private subnets, and those subnets that will be used to, that's where the EC2 instances will be located. So my load balancer was supposed to be in a public subnet, in two public subnets, and my two EC2 instances were supposed to be in the two private subnets. Well, I actually end up having those private subnets also be essentially public. So here I have the workaround. So normally you would not do it. So normally to access your EC2 instances, you would, through the SSH, you would have the Bastion host deployed in a public subnet, and that would be the only machine that is allowed to go in SSH into your private subnet hosted machines. But for me, that just meant that I would need to buy yet another EC2 instance, and that's another cost. So I decided to basically to rely on different security mechanisms like network access control list and security groups to protect my EC2 instances. But I highly recommend you to look into the Bastion host setup for the real life scenario. Here I'm basically essentially having the similar route table that routes all my traffic from private subnets to the internet gateway, and that's basically makes my private subnets essentially public, but I still call them private subnets. So that said, I configured a whole bunch of rules for the network access control list. So we have this massive amount of rules. They basically make up the most, I think, of the CloudFormation template, and they allow you to connect. They allow you to define which ports will be open to communicate between load balancer and your EC2 instances, and between those two EC2 instances and so on. One of the things really to keep in mind always that network access control list is stateless, and that's basically unlike the security group. So normally if you think about firewall, if you open up the port 80, for example, to allow an outgoing connection to web server, you will be automatically accepting the traffic that is containing responses from the web server, and firewall would allow them in because you initiated connection through the port 80 that was originally allowed on that firewall. So that's kind of the responses arrive on any port automatically, and they are allowed. If you have the network ACL, you have to explicitly allow those responses on those ports that they arrive. So that's the tricky part. You have to keep that in mind all the time, because otherwise you'll just run into situations that somewhere traffic doesn't go through, and you just, like, your head explodes because you cannot figure out why, because you configured that traffic to be to be able to go through, but it's not. So yeah, so we have this bunch of rules for access control lists. So I also have security groups. Security groups, they allow me to access my EC2 instances on port 22 for the SSH. They allow the incoming traffic, web traffic for the that goes to the microservices on the ports 8600, 8700, and so on. Yeah, I also allowing those instances to communicate each other. So finally, I have those two instances. So in this case, again, I'm here. You see that there are two T2 micro instances. I actually had to go and change that once I already had everything up and running. So, but here I have this AMI image, and that's the image that I had created with Packer before. So I hard-coded here. It's the same for both instances. You can also pass it through the parameter, but since I'm using just the same one for both instances, I just hard-coded it here. I also assign elastic IP address to both instances, and then I define the security group for my load balancer that allows incoming traffic from my microservices, and I set up the load balancer to be run in two public subnets, and I configure the listener to listen on the HTTPS using that certificate that we pass as a parameter. So, and I have listeners for event service and for web service, and well, I specify my instances as a target group for both services. So basically, this setup allows me to route the traffic from the load balancer to the instances and have it distributed across those two instances. So yeah, and then I actually have I updated the hosted zone. So I have this URL api.kaboom-report.com that is linked to my load balancer, and well, here I have DNS record that actually routes all the traffic that goes to that URL to my load balancer, and this allows me to access my load balancer on this URL. So that's basically it. So we just got reviewed the last piece of the puzzle. So the infrastructure to run my service. Once I had it, once I executed this CloudFormation template on Amazon, I had this I have everything up and running, and well, I could finally access kaboom-report.com and see the events and statistics from my mobile application. So thank you for watching all these videos and staying with me, and have a good day. This is the end of the series. Bye.